Hello, welcome back. Todd here again. More proofs. Okay, let's look at this one. We have to prove this Q and not X, or Q and P. Now, one thing that I notice about that conclusion that we have to get to is there's a Q spread across a disjunction, which means in my mind that a Q had been distributed to a not X and a P, and so this is the same thing as our conclusion. So if we can get to this, we can convert it to what we're looking for by distribution. And I noticed that I have a Q, and so all I would need is this business right here, the not X or P, and I think I can do that too. How am I going to do that? I don't have a not X, but I do have a P, and notice this is an OR. So let's get the P from line 1, P from 1, simplification. That's easy enough. And guess what I'm going to add to the P? A not X, P or not X, 3 addition. I'm trying to build this expression down here. Let me move the pieces to the right position, not X or P, from 4, that's by com. And now, look, I can put the Q and the not X or P together. Q and not X or P from 5 and 2 and 5, let's say. That's conjunction. And as we discovered early on, when we first start thinking about it, we can do a distribution. We're going to distribute the Q to the not X and to the P. Major operator becomes the minor operator, and the minor becomes the major, and that was from 6 by distribution, and that is exactly what we were shooting for. All right, let's move on to another one. Okay, here we have to prove this big ugly expression up here, and notice it is a negated disjunction, so I'm going to write a little mental note down here and remind myself that this is the same as not F if and only if G and H. If I have this, I can convert it to the conclusion up here by De Morgan's. Okay, so let's see if we can get these two parts. A not F if and only if G could come from 1 if I had a not Q, and I do. So that's the first step. Not F if and only if G from 1 and 3. Modus tollens. Okay, so I got this part. Now I need the H. I can get an H from 2 if I have a not Q, and I do. So I get the H. 2, 3 modus ponens, and now I simply put these two together, not F if and only if G and H, 4 and 5, conjunction, and as we said before, this expression we can apply De Morgan's to, and we get not, oops, I need to get rid of that. Not F if and only if G or not H from 6 by De Morgan's, and we're done. How about another? Prove G. Prove G. Look around for a G. There's a G in the disjunct. So we need to get that disjunct and an A to do modus ponens to get to the G. Well, in order to get to this disjunct, we have to get the opposite of the first disjunct. So what we need is, let me write a note down here, what we need is a not L, then M. And here's the thing to notice. If you do a material implication on the not L then M, that's the same as L or M. And now we see how we can do it. We have an L on line 3, so let's add something to it. How about an M? 3 from 3 by addition, because we know we're going to convert this to a then, not L, then M for material implication. And line 5 is the opposite of the first disjunct on 1. So we can do a disjunctive syllogism and get A then G from 1 and 5 ds. And now with the A on line 2, we can get our G to 6 modus ponens. That one was pretty straightforward. How about another? K. Prove K. Well, the only place we're going to get a K is from line 2, but that's going to require a modus tollens. It's going to require L and not M or O. Okay. So I don't see that. So I'm going to have to build it. I need an L, I need a not M, and the or O part I can just add on. So the real task is getting the L and the not M. Actually, the M is ready to go, so the L is the key. Notice there's an L and a consequent on 3, L and a consequent on line 5. That makes me think we're going to do a simple dilemma. I need Q or R, and look what's on line 1. So I get L from 1, 3, 5, simple dilemma. Now I can put things together, L and not M, from 4 and 6, conjunction. Now I'll add on or O from 7 by addition, and this lets me do a modus tollens with line 2